Okay, this video is on log properties, section 4.5. These are some proofs basically of how they are built up so you can understand, and if you forget one you can kind of go back from scratch. But I really strongly encourage you to memorize these and be fluent in them. So here we have two ways to write this. We're going to use U substitution, well, U and then a W substitution as well. So we're going to let U equal b to the x and W equal b to the y. Okay, and we're going to rewrite each of these as log statements. So using what we learned previously. So we would have log our base b of our result, which is U, equals our exponent. Then do the same here for W equals b to the y. So we would have log base b of W equals our exponent y. Using the info above, convert each exponent rule to a log rule. So we have this exponent rule. We know when we multiply exponents that have the same base that we would add the powers. So on this right hand side we would have b to the x plus y. Well, when we have UW, we're going to just carry that down. We will have U times W. We know that U equals b to the x, so that's okay how we wrote this, and W equals b to the y. So now we're going to go to the next line and we're going to rewrite this in log form. So we have UW equals b to the xy. So we're going to write log base b, and then we would have our result, which would be UW equals our exponent up here, x plus y. Okay, so there's a lot of letters happening, but it's the same process, same thing we've been doing. We have this as a product, so we do want to put that in parentheses when we enter it in. Okay, so now what we can do is look back up here and see what x is equal to. Well, x is equal to log base b of U, and y is equal to log base b of W. So now we can replace that. So we're going to write it as this same thing on the right hand side, log base b of UW equals x. So x is equal to log base b of U, and plus y is equal to log base b of W. So this is kind of like how proofs are done. If you haven't done proofs in a while, it might seem a little weird, but we're just kind of manipulating and setting things up so that we can have the same information but presented differently. So now we can use this. It's really important when we have a log of two things being multiplied together. We know we can actually split them apart. So we're going to do the same thing with the quotient. Maybe you could pause the video. I would say you could do this one as classwork and try that one on your own. So go ahead and pause the video and see if you can follow the same pattern that I did of substituting things. Okay, for the first stage we have U over W equals b to the x minus y, using our exponent property there for quotient rule. Now we're going to just rewrite it into log form like we did before. So pause and do that. So again, log base b of our kind of result here, if you will, equals our exponent, x minus y. Now we're just going to sub our x over here and our y over here, and we will be done with our properties. So we're just going to go log base b of u over w in parentheses equals x, which is equal to log base b of u minus y, which is log base b of w. And there we have another property, for when we have division operation. Okay, we have a couple more things to prove out here. We have a situation where we have u to the p. So that would be b to the x, because remember, I'll shrink this down a little bit. We set u equal to b to the x, so we can substitute now our u with b to the x raised to the p. So we're going to see what happens when we have an exponent involved. So we're going to now put it into, well, before I put it in log form, I'm just going to multiply these out. So I have u to the p equals b to the xp, or we could rewrite that as p times x using our commutative property. Now we're going to put it into log form. So we have log base b of our result, which is u to the p over here, equals our exponent, which is p times x. Now we can get everything in terms of u, because we can go look back up here. What x equals is log base b of u. So now we're going to replace that. So we have log base b of u to the p equals p times log base b of u, as we're getting from up here. And that is another property. And this one is pretty common. See that a lot. So it's basically how I kind of think of it is this exponent will come down in front like that. So you may have seen these before if you've done anything with logs. This is a really popular one. One thing we need to note on here is that this is not equal. I'll just put a little note. This is not the same as if we had parentheses around the whole log like this. Log base b of u all raised to the p. That's not what this property is saying. Okay, so you really have to note if there's where the parentheses are. You can have it actually look like this would be okay. A lot of times it just looks like this, log base b of u to the p. There's not parentheses around the u to the p. Just want to clarify that. So the next one we have is rewrite log base b of w equals y in terms of logs with a base of c. So this is called our change of base formula. So that way we really like to have the same base a lot of times, and actually like common log, we can get it into that too. So that's really nice. So what we'll start with is, again, just writing our substitution in there. So we have b to the y equals w. So we actually just put this log form in exponent form. Okay. Just kind of rearranging it. Now we can do what's called take the log of both sides. As long as we do that to both sides, we have an equivalency happening. So then we would have log, and I'm going to use a base c of b to the y equals log base c of w. Now I can use my exponent properties to solve for y. So I'm going to take log of both sides and then solve for y. So here I have this property that I just finished earlier. I can kind of bring down that y in front. So I have y log base c of b. And that is equal to log base c of w. And now I can divide both sides by log base c of b. And that will give me y by itself equal to log base c of w over log base c of b. But remember, y actually equals, right up here from the beginning, y is going to be log base b of w. So we'll just go ahead and replace that right there, log base b of w. So now we have this change of base property, which is really nice. So basically, you have to just think of it this way, as to memorize it. This stays in the top. You're changing the base to whatever you want. Like you could have it be 10, as long as it's the same base in the numerator and denominator. So I could do a common log and be able to use a calculator this way. And then log base b goes on the bottom, but remember you have to have these being the same thing, which is usually base 10, or it could be a natural log or something like that. So it's like this is the numerator and this goes in the denominator. So that's just a quick way to think of it. So that's the video for our properties. I'm going to leave that as part 1, and then we'll do some examples using those properties, and we might see some more things along the way, some more patterns. We did notice some earlier when we did the intro. We developed some properties as well. So I will post a sheet for you guys that has them all on one thing, and you can use that to memorize from. All right, have a great day.